Internusa heating element proudly presents the importance of heating elements in industry, function and applications. The story of the heating element, a vital component for industry. 1. In the world of industrial machinery and processes, heating elements play an essential role in various applications, from manufacturing to refining. These simple yet powerful components convert electrical energy into heat energy, making them indispensable in industries that rely on controlled heat, such as plastics, chemical production, food processing, and metallurgy. 2. A heating element is essentially a piece of wire or strip made from materials with high electrical resistance, such as nichrome, a nickel, chromium alloy. When electricity flows through this resistant material, it encounters friction, generating heat. This heat can then be used to warm objects, spaces, or materials, allowing industries to execute specific tasks like melting, drying, or cooking. 3. The versatility of heating elements makes them widely applicable. In a plastic extrusion process, for example, they are used to soften and melt plastic pellets, which are then shaped into products like pipes or sheets. The precise control of heat ensures that the plastic material flows evenly and doesn't degrade, which could otherwise affect the product quality. 4. Heating elements come in various forms depending on the industry's needs. Tubular heaters, for example, are commonly found in machinery, where heat needs to be distributed over a large area. Cartridge heaters are small but powerful elements, used in precision equipment, like molding machines, or packaging devices, where consistent temperature control is critical. 5. One of the most significant advantages of using heating elements is their efficiency. Because they convert electricity directly into heat at the source, very little energy is wasted. This is especially important for industries that aim to optimize energy usage and reduce costs, helping them maintain profitability while meeting environmental regulations. 6. However, selecting the right heating element requires an understanding of the operating conditions. For example, if a heater operates in a high-moisture environment, such as food processing plants, it must be designed to resist corrosion. In contrast, for high-temperature environments like kilns or furnaces, the heating element material must withstand intense heat without breaking down. 7. Over time, heating elements can wear out due to repeated thermal cycling where they are heated and cooled multiple times. The expansion and contraction of the element material can lead to stress and eventual failure. Regular maintenance and replacement schedules are critical to prevent downtime and ensure that machinery continues to run smoothly. 8. Temperature control is also a major concern in industries using heating elements. Sophisticated sensors and controllers are often integrated into systems to monitor and regulate the temperature. A failure to maintain proper temperature can lead to uneven heating, material waste, and even safety hazards in some cases, such as overheating or fires. 9. One exciting innovation in heating element technology is the development of more durable materials and advanced control systems. These new designs improve longevity, performance, and efficiency. As industries increasingly adopt automation and precision technology, heating elements are becoming smarter, integrating with IoT devices for real-time monitoring and data analysis. 10. In conclusion, heating elements may appear as simple components, but their importance in industrial processes cannot be overstated. From manufacturing to energy management, they provide the heat needed to drive productivity and innovation. By understanding how they work and selecting the appropriate type for specific tasks, industries can ensure both quality and efficiency, securing their place in a competitive marketplace. Thank you.